So let's dive into the register that kind of, stores information about the computational state of the CPU. What does computational state mean? So it's as if like, it's keeping a track of what the answers or not answers, but did the computation lead to, for example, an overflow, right? Where the 64 bits not enough, right? Did the answer go over 64 bits? So it stores status of that nature. And let me just kind of get rid of this, maybe, right. This is a good color. Nice. So the processor state, this register is used for example, branching, right? And what does branching mean? So branching is essentially an implementation, underlying implementation, or what the if condition would translate into. So if condition translates to a branching instruction, loops translate into some sort of branching instructions. And branching essentially means this: hey, if x equals y, then jump to, let's say, hex ABCD being an address. So the way to read this is you can perform x minus y, and if that equals 0, so in this processor state register, there is a bit that tracks 0 was generated or not. And if 0 is generated, then it's like, okay, branch on 0, right? So there is an instruction like this, right? Branch link 0, branch 0. Again, I might be getting the exact instruction wrong, but there are instructions of this nature. So then let's take a look at, what this um, register actually conveys. So first off, recall that we had seen something of the name CPSR, right? The current program state register. And this was kind of, referred to by this name on the V7 architecture as well, right? And the essentially this is in the V8 architecture referred to as the P state. Now, why am I stressing about this, right? Let me just go back to this screen here, and you would have noticed that earlier we had somewhere seen CPSR, right? But the CPSR is essentially the P state register. P state is on V8, 64-bit architecture, and CPSR is the name that it had for the V7 architecture. Well, I just want to kind of, call out that the names are essentially architecture specific, but the information conveyed is exactly kind of, the same. Right. So now what are the different things that it can convey or it can record in terms of state? Okay, negative condition flag was a negative number generated. Was there a 0 generated in the x minus y example? Right. So it'll record this. Was there a carry generated? Right. Did an overflow happen? Was the CPU under debug? Right. Did some sort of an asynchronous error happen? Did an interrupt happen? Did a fast interrupt happen? Uh, are we supposed to be in a mode? Are we meaning the CPU? Is it supposed to be in a mode where after every instruction it pauses? Right? Did illegal execution happen? Was the interrupt, not interrupt, but the instruction itself illegal? And was it corrupted? Something of that nature that is stored here. Now, there are more bits here. So EL, for example, which exception level is the CPU in? Right. So that is it EL0, EL1, so on and so forth, right? EL2, EL3, so on and so forth. And then which stack pointer, the CPU is using. And also, is this CPU in 64 or 32-bit execution mode? Now, this requires a little bit of explanation. So although we talked about, or we are focusing on the AR64-bit or the V8A architecture, and we talked about execution levels uh, to real 3. The idea is that the V8 architecture is backwards compatible with V7, and V7 was for 32 bits, right? So let's say you had an app that ran on the V7 architecture, which was 32-bit. The same app is supposed to be able to run on the V8 CPU as well. So how can that happen? So it turns out that a 64-bit, if your OS is 64-bit, then apps of 32-bit and 64-bit can be run on this, right? And that mode of operation, whether to read the instructions as if they were for the V7 architecture and 32-bit processing, that needs to be kind of set here, or that will be inferred, so to speak, from this bit. So this essentially then is the summary of the P state register, one of the very important registers that we care about. And you can go ahead and read 4.2 section of the document that we are following. In the next one, we are going to take a look at how the CPU deals with exceptions, and then few registers that are related to exceptions.